Hi everyone, welcome to SKM Academy. Today we are going to see Physics 12th, Chapter 1, Example 1.4. So, in Example 1.4, they are given as a charged metallic sphere A is suspended by a nylon thread and another charged metallic sphere B held by an insulating handle is brought close to A such that the distance between their centers is 10 centimeter as shown in the figure 1.4a, like this. And then the resulting repulsion of A is noted, for example, by shining a beam of light and measuring a deflection of its shadow on the screen. Spheres A and B are touched by uncharged spheres C and D respectively as shown in the figure 1.4b. See figure 1.4b like this. C and D are then removed and B is brought closer to A by the distance of 5 centimeter between their centers as shown in the figure 1.4c, like this. So what is the expected repulsion on A on the basis of Coulomb's law? Then they given a sphere A and C and the sphere B and D have identical sizes. Ignore the sizes of A and B in comparison to the separation between their center. So in initial situation, that is see figure A, here the sphere has the charge, sphere A has the charge, has Q1 and the sphere B has the charge Q2. Sphere A has the charge Q1 and sphere B has the charge Q2 and the distance between the centers were 10 centimeter, which is the value of the R. So we know that the electrostatic force F is equal to K Q1 Q2 by R square. If this is the initial condition, say it is F1. In second diagram, they have given us touching with the uncharged sphere. That is, the sphere A is touched by an identical uncharged sphere C. Since A and C are identical, the charge were divided equally, so that it becomes a charge on A is reduced as half, so Q1 by 2, like that. Similarly, B is identical, touched by an identical uncharged sphere D, so charge on B also reduced by half B, which is equal to Q2 by 2. And in third case, they have reduced the distance. So B is brought closer to A and the distance is reduced to from 10 centimeter to 5 centimeter. So R new distance R prime, which is equal to 5 centimeter, that is reduced to half, so that the new force can be written as F of 2, which is equal to K Q1 by 2 into Q2 by 2 by R by 2 square. So after simplification, F2 will be equal to K q1 q2 by 4 into 4 by r square. So 4 will get cancelled. So F2 which is equal to K q1 q2 by r square. So initially we noted that F1 which is equal to K q1 q2 by r square. So since both are equal, F1 which is equal to F2. So the final conclusion is when the charges on both the sphere becomes half and the distance between them becomes half, the decrease in force due to reduced charge is exactly compensated by the increase in force due to reduced distance. Hence, the repulsion remains unchanged. So the final answer will be the expected repulsion of the sphere A is same as that of above. So F1 which is equal to F2. So thank you. We see you next video.